Welcome to The Explainer. Today, we're going to tackle one of the most talked about technologies out there, blockchain. We're going to build it from the ground up, piece by piece, starting with the basic problem it solves, all the way to a whole new system of digital trust. To really get our heads around it, we'll build our understanding in 5 simple layers. First, we'll look at the fundamental problem of digital trust. Then we'll introduce this idea of a shared digital notebook, see how it's built with blocks, discover the crypto-powered glue that holds it all together, and finally, figure out how everyone on the network actually agrees on what's true. All right, let's kick things off at the very beginning with our first section, the problem of digital trust. I mean, we do this all the time, right? Buying stuff, sending cash to friends. But have you ever really stopped to think about how that actually works? How do we manage to trust a complete stranger on the other side of a screen? Well, the truth is, we don't. We trust a middleman. Banks, credit card companies, you name it. These big centralized authorities sit right in the middle of pretty much everything we do online. They verify it all, but that also creates a single point of control and, you guessed it, a single point of failure. And that is the exact problem blockchain was designed to solve. It's a huge shift in how we think about trust online, allowing us to deal directly with each other without needing those powerful companies in the middle. But how on earth does it do that? Well, it all starts with a really simple but powerful idea. So how does this all work? It starts with the big picture concept that blockchain is a part of. Think of it like a shared notebook. The technical term for this is distributed ledger technology, or DLT. So what is a distributed ledger? Just picture that shared digital notebook, but instead of one person or one bank holding the master copy, everyone in the network has their own identical copy. The database is literally spread out across thousands of computers, and they all stay perfectly in sync. Now, this kind of setup gives it some incredible features. It's decentralized, so no single person is in charge. It's immutable, kind of like writing in permanent ink. You can't go back and change what's already been written. You can only add new records. It all comes together to create a system that's transparent, super resilient, and acts like a digital notary that can't be tricked. Okay, so we've got this idea of a shared ledger. Now let's get a little more specific and see how a blockchain, which is just a special type of DLT, is actually put together. You know, the name itself pretty much tells you everything you need to know. It's a type of distributed ledger where all the data, like our transactions, gets bundled up into these packages called blocks. And then these blocks are cryptographically linked together to form, well, a chain. It's just a continuously growing list of records. Simple as that. Let's zoom right in on a single block. You can think of it like a secure digital safe. Inside, it's holding a bunch of transaction data, a timestamp saying when it was created, and this is the secret sauce, a unique digital fingerprint or a hash of the block that came directly before it. And this is where you see the chain part really come to life. See that? The prev hash in block 2 is the exact same digital fingerprint as the hash from block 1. This creates that super secure cryptographic link, locking them together in a perfect, unbreakable sequence. And here's why that is so important. Because each block is linked to the one before it, trying to change anything is basically impossible to hide. If you tried to tamper with a transaction in an earlier block, its digital fingerprint would change, which would instantly break the chain. The whole network would see it, making any fraud stick out like a sore thumb. So you might be wondering, what makes this chain so incredibly strong? Well, the magic ingredient is something called cryptography. It's the powerful, invisible glue that holds this entire system together. At the heart of it all is the cryptographic hash. Think of it like a machine that can take any digital info, a document, a picture, a transaction, and turn it into a unique, fixed-length code, a digital fingerprint. And here's the wild part. Change just one single comma in the original data, and the fingerprint that comes out is completely different and totally unpredictable. So how do we prove we own our stuff and authorize transactions? This is where a really clever system of keys comes into play. You get a public key, which is kind of like your bank account number. You can share it freely with anyone who wants to send you something. But you also get a private key. Now this is your secret. It's your password. You never, ever share it. You use it to create a digital signature that proves you approved a transaction. So let's put it all together. You basically have 3 cryptographic pillars holding everything up. Hashing algorithms link the blocks and guarantee the data's legit. Asymmetric cryptography, that public and private key combo, is how we identify users, and digital signatures are what authenticate every single transaction. Together, they create this fortress of security and trust. Okay, deep breath. We have a secure, distributed chain of blocks, but there's one final, absolutely massive piece of the puzzle. In a global network of strangers, with no one in charge, how does everyone agree on which blocks get added to the chain? The solution is something called a consensus mechanism. Just think of it as the network's official rulebook. It's the protocol that lets all of these scattered computers reach an agreement, or consensus, on the current state of the ledger. This is absolutely critical for stopping fraud, like someone trying to spend the same digital money twice. So the huge question is, how do they actually do it? How does a network of thousands of independent computers who don't necessarily trust each other establish a single shared source of truth? Well, Bitcoin's original solution, and the most famous one, is a process called proof of work. Okay, here's how it works. First, new transactions are broadcast to everybody on the network. Then, these specialized computers called miners all start competing in a massive race to solve a really hard math puzzle. The first miner to find the solution gets to create the next block and broadcast it to everyone else. The other computers can verify that the solution is correct almost instantly, and if it is, boom, that new block is added to everyone's copy of the chain. This whole process takes an immense amount of computing power, which makes it incredibly difficult and expensive for any bad actor to cheat the system. So, let's wrap this all up. A blockchain is a special kind of shared notebook, a distributed ledger. All the data gets stored in blocks, which are linked together into a chain using those cryptographic hashes. That's what makes it so secure and unchangeable. Digital signatures prove who owns what, and a consensus mechanism is like the engine that gets the entire network to agree on a single shared truth. So now that you understand the fundamental building blocks, it leaves us with a really fascinating question. What could a world actually look like when it's built on this new kind of digital trust, without the need for all those middlemen? That's the question that's driving all kinds of innovation in areas far beyond just currency, from making supply chains more transparent to building entirely new systems for voting.